Hello students, in this video I will try to explain effect of gyroscopic couple on a naval ship. Here I have drawn three views of a naval ship: front view, top view and side view. Now there are three axes: x-axis about which this rotating parts, this is propeller of the ship, and this is other rotating parts like turbine blades. These are spinning about x-axis. Now this is y-axis and z-axis is shown as a point here in front view. When you look from top, this z-axis is visible. This is z-axis. X-axis is also visible, but y-axis is appearing as a point here at this point. When you look in side view, when you look from this side, this is side view, and side view x-axis is not visible. It is appearing as a point here, and this is y-axis and this one is z-axis. Some terms used in a naval ship are: first, the fore end of the ship is called bow. This is bow. This part of the ship is called bow. This part of the ship, rear part, is called stern or aft. Left part of the ship is called port, and right part of the ship is called starboard. We will study effect of gyroscopic couple on these three types of motion: rolling, pitching and steering. Rolling is the tilting motion of the ship from side to side, and this motion is visible in side view. Here in side view you can see the ship tilts in this manner, in this direction and this in this direction. So this tilting motion is taking place about x-axis, which appears here as a point. It looks something, it will look like this. In this motion you can see that axis of spin, all these rotating parts are spinning about x-axis, and at the same time axis of precession, both are x-axis. So this rotating parts or spinning parts are spinning about x-axis. At the same time rolling also takes place around x-axis. Therefore there will be no gyroscopic couple, because for the effect of gyroscopic couple to occur, the axis of precession should always be perpendicular to the axis of spin. But in this case both axes are parallel to each other. So you can calculate gyroscopic couple using the same formula I omega omega p, but there will be no effect of gyroscopic couple on the ship. Next motion is pitching, which is up and down motion of a vessel about z-axis. Now this z-axis is appearing as a point here. So about this z-axis, this portion, this ship is tilting up and down. So this motion like this. Now in this, gyroscopic couple is same I omega omega p, where I can be calculated as mk square, where m is mass of all the rotating parts, all the spinning parts, k is radius of gyration. Now omega can be calculated using relation 2 pi n divided by 60, where n is rpm of this shaft or rpm of this rotating parts. To calculate omega p, first we should assume this pitching motion as a simple harmonic motion. So if it is a simple harmonic motion, it is moving up and down. So this angle is phi, which is the maximum angle by which this axis is tilting in upward direction. Similarly, maximum angle by which it is tilting in downward direction is also phi. So this is the mean position of the x-axis, and this x-axis is moving from this position to this position. That is, phi is called amplitude of simple harmonic motion. This is the maximum displacement from the mean position, maximum angular displacement from the mean position of the x-axis. So once you get this amplitude, you can define simple harmonic motion as theta is equal to phi sine omega o into t, where theta is the angular displacement from the mean position at time t. This theta can be calculated using this term. So this is the maximum displacement, that is amplitude, and omega o is the angular velocity of simple harmonic motion, and it is calculated as 2 pi divided by time period of SHM. So what is time period? Now you can see that this x-axis is moving upward direction, reaching maximum position. Then after it comes down to this lowest position, and then again it will reach to its mean position. So this is called one complete cycle. So time taken to complete this one cycle is called time period of simple harmonic motion. So from that time period you can calculate omega o, which is the angular velocity of simple harmonic motion. Now angular velocity of precession can be calculated by differentiating this theta with respect to time. So d theta by dt that is omega p, angular velocity of precession, and if you differentiate this, you will get phi omega o cos omega o into t. So when you put this value of omega p here, you can see this couple is varying with time. With time, this couple will change. But most of the time, we are interested in maximum value of this couple. It will be the maximum when omega p is maximum. So maximum value of omega p, here phi and omega o both are constant. So maximum value of omega p you will get when you will get maximum value of cos omega o t. And we know that maximum value of cos omega o t is equal to 1. So maximum omega p is equal to phi into omega o, where cos omega o t is equal to 1. So that is when this axis is at mean position, at that time velocity will be maximum, and at that time you will get maximum gyroscopic couple. You can calculate angular acceleration of this simple harmonic motion by differentiating omega p once again with respect to t. Then you will I have differentiated here this, so you will get phi omega o square sine omega o t. Omega o t. Negative sign shows the direction of the acceleration. So maximum value of acceleration will be, again, maximum value of sine omega o into t is 1. So maximum value of angular acceleration will be phi omega o square, and this is equal to omega o into omega p max, because omega p max is phi omega o. So omega o into omega p max will be alpha max, that is maximum value of angular acceleration of this simple harmonic motion. So this is the calculation part. Now what will be the effect of this gyroscopic couple on this ship? For that we have to draw vector diagram. For that, first assume what is the direction of rotation of this spinning bodies. So I have assumed the spinning bodies are rotating in anti-clockwise direction when looking from the bow side, that is front side, it is rotating in anti-clockwise direction. So if it is rotating in anti-clockwise direction, then momentum vector can be drawn using right hand screw rule. So if right hand screw rotates in anti-clockwise direction, then this screw will move in right side direction. So vector will be along this direction, in this direction. So I have drawn this vector in vertical plane. So this is this axis is moving about z axis in vertical plane. So I have drawn one vertical plane. So this is your initial momentum vector. Now we are taking the condition when this bow is descending, it is coming downwards direction. In that case, if you use right hand screw rule, this will be the direction of vector. So I have drawn this vector. So this is the vector after some time d, after a small time t. So this is initial momentum, this is final momentum. From the end point of initial momentum to end point of final momentum will be the direction of active gyroscopic couple, and reactive gyroscopic couple will be just opposite to this. If reactive gyroscopic couple vector is acting in vertical plane, that means reactive gyroscopic couple must be applied in horizontal plane. So if vector is in vertical plane, then couple will be applied in horizontal plane. Now direction of vector is pointing upward direction. So according to right hand screw rule, this direction will be obtained by an anti-clockwise couple. So in this you have to apply one anti-clockwise couple, then you will get this reactive gyroscopic couple vector. So this vector is applied in this, reactive gyroscopic couple is applied in the ship in this way. The effect of this gyroscopic couple will be to turn this bow towards port side. So in this way it will tilt. So gyroscopic couple will tend to move the ship towards port side. Now what if it is going upward direction, or if this ship is ascending? In case of ascending, the direction of momentum will be towards this side using right hand screw rule. So first initial vector I have drawn here, horizontal, and this is the final momentum. This is the final momentum I have drawn here in this direction when it is going upward or when this bow is ascending. In that case, from the end point of first vector to the end point of second vector, this will be your active gyroscopic couple. So reactive gyroscopic couple will be just opposite to this, pointing downward direction. Now this reactive gyroscopic couple vector is in vertical plane again, then therefore this couple must be applied in horizontal plane. So this horizontal plane, and this is the reactive gyroscopic couple vector. So this vector will be obtained by applying a couple which is clockwise when looking from the top, then according to right hand screw rule. So if you use a right hand screw rule, if you rotate this right hand screw rule in clockwise direction, you will get this direction of vector. So effect of this couple on this ship will be, I have drawn this couple, clockwise couple. So effect of this couple will be to turn the bow towards starboard side. So this will try to turn the bow towards starboard side. In this way you can determine effect of gyroscopic couple when this direction of rotation is clockwise. If direction of rotation of spinning bodies is opposite, then using same method you can determine the effect on this ship. Third condition is steering condition. So I have drawn only top view of this ship here, and suppose direction of rotation of this spinning bodies is anti-clockwise when looked from the forend, and it is taking turn in right side direction. Gyroscopic couple will again be given by same equation, I omega omega p, where I is equal to mk square and omega is equal to 2 pi n by 60. Only thing we have to calculate omega p. For that you need speed of this ship, or velocity of this ship is v, which in meter per second, and radius of rotation of this curve, or this radius of rotation, or this radius of curvature is r in meters. In that case omega p is calculated using relation v by r. The effect of gyroscopic couple on naval ship during steering is very much similar to which we have studied for aeroplane. So this is how we calculate gyroscopic couple in case of steering. Now to determine its effect, now this is anti-clockwise direction. So using right hand screw rule, the direction of vector will be towards right. So this is in horizontal plane. So I have drawn horizontal plane here, and initial vector I have drawn. Now it is taking turn in right direction. So it is taking turn like this. So now in this case the direction of vector will be this one, anti-clockwise. If you rotate screw in anti-clockwise direction, it will move in this direction. So this is your final vector. Now difference of these two vector can be obtained by joining line from end point of first vector to end point of second vector. So this is the difference, which is the equal to which is the direction of active gyroscopic couple. So reactive gyroscopic couple will be just opposite to this. So this is reactive gyroscopic couple. Now reactive gyroscopic couple vector is acting on horizontal plane. Therefore this reactive gyroscopic couple must be applied in a plane which is perpendicular to this, that is vertical plane, which is perpendicular to this vector. So I have drawn this vertical plane, and this plane is perpendicular to this reactive gyroscopic couple vector. Now this vector is pointing towards this direction. So this direction, if you can get this direction of vector by applying a couple in this vertical plane in clockwise direction. So from right hand screw rule, if you use a right hand screw, clockwise motion will give you this direction of motion. So reactive gyroscopic couple will act in this vertical plane in clockwise direction. So this effect, the effect of this couple, this clockwise couple will be shown in this front view in vertical plane. Front view is drawn in vertical plane, we know. So this is the direction of couple, and effect of this couple is to lower the bow. So effect of the reactive gyroscopic couple will be to raise the stern and lower the bow. In this way you can determine the effect of gyroscopic couple on different conditions. So let's take one example here. The rotor of the turbine of a ship has a mass of 2500 kg and rotates at a speed of 3200 rpm counterclockwise when viewed from the stern. The rotor has radius of gyration of 0.4 meter. Determine the gyroscopic couple and its effect when the ship steers to the left in a curve of 80 meter radius at a speed of 15 knots, where 1 knot is given 1860 meter per hour. Second condition is the ship pitches 5 degree above and 5 degree below the normal position, and the bow is descending with its maximum velocity. The pitching motion is simple harmonic with a time period of 40 seconds. Third condition is the ship rolls, and at the instant its angular velocity is 0.04 radian per second clockwise when viewed from the stern. Also find the maximum angular acceleration during pitching. This question I have taken from the book of Theory of Machine by S S Rattan. In that book, this you should correct this. This value is given 0.4 radian per second, but you correct this as 0.04 radian per second. Now in this problem, gyroscopic couple in all the three cases will be given by I omega omega p, where value of I is mk square, which we can calculate mass 2500 kg, and radius of gyration is given 0.4 meter, 0.4 square. From that you are getting 400 kg meter square as I. Omega is 2 pi n by 60, where n is given rpm, which is equal to 3200. Putting this value here, you will get value of omega as 335 radian per second. Now these two are common for all the three. Other things we can calculate one by one. So first condition is the ship steers to the left in a curve of 80 meter radius at a speed of 15 knots. Now here rotating parts are rotating in anti-clockwise direction when viewed from the stern side, counterclockwise direction when viewed from the stern. So I have drawn this counterclockwise direction when viewed from the stern. It means if you look from the bow side, this rotation will be clockwise, and this is steering towards left at a curve of 80 meter radius. So radius of this curvature is 80 meter. Now omega p we know can be calculated using V by R relation, where V is the velocity in meter per second. Now velocity is given in knots, so you have to convert that into meter per second. So I have converted that 15 into 1860 meter per hour. So to convert that into per second, I have divided by 3600, and R is the radius of curvature in meters. So this is 80 meters. So I have put value of R as 80. If you calculate this, you are getting omega p as 0.097 radian per second. So you can calculate gyroscopic couple I omega omega p, which is coming as 12,981 Newton meter. Now effect of this gyroscopic couple we need to determine. Now this rotating parts are rotating in clockwise direction when viewed from the bow side. So from right hand screw rule, if you rotate right hand screw in clockwise direction, it will move in this direction. So this is your initial momentum. So in horizontal plane, this I have drawn top view in horizontal plane. So this is your initial momentum. Now it is taking turn. So after taking turn, its direction will be like this. So you will get momentum in this direction using right hand screw rule. So from the same start point, I have drawn this direction. So end point of this to end point of this will be your direction of active gyroscopic couple, and reactive gyroscopic couple will be just opposite to this. Now we know that if reactive gyroscopic couple vector is acting in horizontal plane, then reactive gyroscopic couple must be applied in vertical plane, which is perpendicular to this vector. So I have drawn one vertical plane which is perpendicular to this vector. I have drawn this vector here. So this vector can be obtained by applying this gyroscopic couple, reactive gyroscopic couple, which is clockwise, because according to right hand screw rule, if you rotate right hand screw in clockwise direction, the screw will move in this direction. Now this effect can be visualized in front view. So I have drawn front view of this ship. So in this front view, couple is applied in clockwise direction. So effect of this couple will be to lower the bow. So effect of the reactive gyroscopic couple will be to raise the stern and lower the bow. Next condition is pitching, where value of phi is given 5 degree. Now it is in given degrees, so you have to convert this into radians. For that I have multiplied with pi by 180. From that, pi means 3.14. So from that you are getting 0.087 radian. Now omega O is given. Omega O you should calculate using 2 pi by t. So 2 pi 2 into 3.14, and time period of the simple harmonic motion is given 40 seconds. So using this relation, you are getting omega O, that is angular velocity of simple harmonic motion, as 0.157 radian per second. Omega p, maximum value of omega p, because we have to determine gyroscopic effect when it is descending with its maximum velocity. So omega p maximum value of omega p is 5 omega O. From this you are getting 0.0137 radian per second. So gyroscopic couple will be I omega omega p max. So I omega omega p max, and its value is 1836 Newton meter. This is the couple which is acting during pitching. Now we can calculate maximum value of acceleration also, because alpha max is equal to 5 omega O square, or omega O into omega P max. So omega O we have calculated this one 0.157, and omega P max is 0.0137. Multiply these two, you will get this as maximum angular acceleration. To study the effect, I have drawn this view here. Now this all rotating parts are rotating in clockwise direction. So this will be the your initial momentum vector. Just drawn this vector in vertical plane. This is vertical plane, so this is initial momentum. Now this is descending, so this bow is coming downward direction, so this will be the new position, descending position. In this case, direction of momentum vector will be this one. So from the same start point, you have to draw this vector. I have drawn this vector. So from end point of first vector to end point of second vector is the difference, and this is your direction of active gyroscopic couple, and just opposite to this will be reactive gyroscopic couple. Reactive gyroscopic couple vector is acting in vertical plane, then reactive gyroscopic couple must be applied in horizontal plane. So this is horizontal plane, and this vector is vertical downward direction. So vector is vertical downward direction. So reactive gyroscopic couple must be clockwise direction according to right hand screw rule. Effect of this clockwise couple on this shape, which it will be visible in top view, because this is horizontal plane, so top view is drawn in horizontal plane. So this is the clockwise couple. Effect of this clockwise couple is to tilt this boat towards starboard side. So the effect of reactive gyroscopic couple will be to turn the ship towards starboard side. Now third is, the ship rolls, and at the instant its angular velocity is 0.04 radian per second clockwise when viewed from the stern. So here we can take omega P is directly given 0.04 radian per second. From that you can calculate gyroscopic couple as 400 into 335 into 0.04 is equal to 5360 Newton meter. As we have discussed before, in rolling there will be no effect of gyroscopic couple on the ship motion. So thank you for watching this video.